Good morning, everybody, and welcome. Welcome to episode 29 of MakerBot Chats. My name is Felipe, Creative Director at MakerBot, and today we've got an exciting one. Metals, just announced yesterday. Well, metal 3D printing, right? With the method. So yeah, this morning is essentially going to be all about metal, what we announced yesterday, what the material is, how you can print with it, how you can run it in the method, which is running in the background right here. And basically an open forum for you guys to ask any questions that you may have about the material itself. I'm going to start sort of with the easy part, right? What it is and what did we announce just yesterday. So starting now, you can now print or 3D print metals with method, right? All of the method printers, that means the regular method, method X, if you got a method carbon fiber edition, will be able to print with metal. And it's super exciting just because of the amount of possibilities that this material opens. It comes with a lot of, I would say, maybe disclaimers is the right word, but it's just, you have to be really thoughtful of what you're trying to print with it, right? It's definitely a great material. There's a lot of possibilities with it, but it's part of our labs platform, right? So that means it's a third-party material, being distributed by Matter Hackers mostly. Well, I've got it through Matter Hackers. The material itself is called BASF Ultrafuse 3116L. The 3116L stands for the actual grade of the stainless steel that you'll be getting from your parts. But as I was saying before, this is meant to be used with our labs platform, right? You will need the labs extruder, which is visualized right here, as well as the method printer. So any of the method printers, as I said before, the labs extruder, and of course the filament itself, which comes from BASF. I've got mine from Matter Hackers. There's a bunch of resellers out there that will distribute the BASF. It has to be the 1.75 millimeters in diameter. But essentially that's all that you need, right? It's just if you don't have the labs extruder and you have already a method printer, all you need to do is to get the labs extruder and you're ready to go. I'll walk you guys through the process of it. I don't know if it's tricky. It definitely adds a few steps to the printing process. That looks like, that's why we have these kind of nice graphics on the side explaining that. Instead of directly getting metal parts or immediately getting metal parts out of the printer, what you're going to get is something that looks a little bit like I've got here, right? It's what they call a green part, and this is what the top gear shows. The green part is the first thing that you will get out of the printer, right? It's kind of a super dense part, but it still has that binding agent. It still has that polymer that allows you to essentially be able to use it in a 3D printer, allows you to actually print the stainless steel in the 3D printer, right? Once you printed your part, and there's a few considerations, and we'll talk about those in a second, but once you printed your part, you will need to send it to be processed. Why? Because you will need the part to be sintered. Essentially what happens is they cook your part, similar to what you could imagine a ceramics process, kind of. So you'll send it over. Matter Hackers offers that service as well, and they'll sinter it, which means they'll heat it up to about 5,000 degrees Celsius, 1,200 degrees Celsius, and remove the binding agent, right? So it's not only the heating part, but it's also the fact that it's being exposed to a pure hydrogen atmosphere, so removing any sort of extraneous material and leaving behind only the sintered part. The sintered part itself, much shiny, and I'll have like close-ups of the parts in just a second, but the sintered part itself is what's coming back to you. So you're sending your part, like literally sending it through mail, and you're receiving back the sintered part, which is essentially the cooked part, right? But now this part, and this is what I love, let me bring this closer to the mic. Now this part is 100% stainless steel. It's like solid steel. It's amazing. We'll talk about the weight, we'll talk about the qualities of the material, but that's all there is, right? You print your part, you send your part, and you get it back. Throughout the process, there's a few considerations that you have to have regarding the geometry, the applications, the actual constraints when printing it. Like for instance, you won't be able to use supports. You can use supports, but anything that you send out for sinter will come back as solid metal, right? So you have to be very cognizant of that. Personally, I would recommend trying not to use supports. You can also design supports if you want to do it manually. But yeah, any sort of support structure will be baked into the part, and then will be really hard for you to remove it afterwards, right? So I would say no supports. Also, if you think about, for instance, printing with supports, removing the supports, sending the part for sintering, during the sintering process, the part itself will also require the supports, right? Because as the part is being heated up, it will lose some of its rigidity in the process, and because of that, any sort of overhangs, any excess geometries can collapse on its own weight. So anything that's not self-supported will be really difficult for you to not only print but also sinter and get back successfully. Finally, some the actual tech specs of the material. It can be heated up to 550 degrees Celsius. That's a lot. I mean, the closest material that we currently have would be the carbon fiber, and that I think goes to 150 or 180. I'm not sure. I would have to double check the data sheets. But this is like, it is stainless steel, which like blows my mind, right? I cannot wait till I show you like the zoom version of these parts. But it's stainless steel. It has an incredible strength. It is steel, incredible hardness. You can also download the data sheet. Just clicking the icon there will open the data sheet. It will come with everything that you need to know. The printer that you'll need, the extruder that you need, the material that you will be using, some examples. I'll be talking about the examples here in just a second. The process itself, as I was saying, print it, send it, receive your stainless steel part. But yeah, I think that's all there is. And of course, the fact that you can print it with any one of our 3 method platforms or method versions. It's possible to print it with the regular method, the Method X, and of course the Method Carbon Fiber edition. So yeah, if you're interested, I would highly recommend requesting a quote. There's still a promo going on Method today. And by the way, I'll be taking questions. If you have any questions, just post them on the right-hand side of the video. Alejandra is collecting all of them for me. She's our producer extraordinaire behind the scenes. But I'll be taking the questions that you may have, and in the meantime, let me fade here. I'll be showing you some of the parts that I have printed, and I'm actually printing one extra part right now. So yeah, if you have any questions on those, do let me know. You can post them in the chats, and I'll just walk through some of the parts that I printed, some of the issues or difficulties that I found, best practices, and also the reason why I've got the scale right here is because I wanted to show you guys like how dense these parts are. I'll start with just a quick overview of some of the parts that I've gotten back from Matter Hackers, some of the parts that have been successfully printed out and sintered, starting with this gripper element, right? Let me bring it back to the camera, closer to the camera. So, well, I'll keep it this way. This part, the part on the right, the one that's actually a little bit darker, this is what I've been calling my green part, right? The green part is the part that actually comes out of the printer when you first print, your part. As you can see, there's a noticeable size difference between the 2 parts. Why? Because during the sintering process, the part will shrink quite a bit, as much as 20%. And actually, we have from BASF, we have the guidelines, the design guidelines on how to actually scale up your parts. You will lose about 20% in X and Y, that's due to shrinkage, and about 26% in Z, right, on the Z axis. So you'll have to consider that when printing. In MakerBot Print, and I'll talk about MakerBot Print in a second, but in MakerBot Print, there's already being deployed an update on printing with metal. So you'll be able to just select metal from either MakerBot Print or Cloud Print and print with the material. And that update will cover you for this shrinkage happening in the material, right? But you can see how the green part, this darker part, is way bigger than my actual sinter part. So this part is the actual end result or end part that I got from Matter Hackers after it was processed. And a couple of things to note. First off, on the green part, just as ever with Method, the quality that you're getting, the quality of the parts, let me make sure that I'm actually focusing correctly, or the camera is focusing correctly. Let's see, maybe a little bit further away. Closer in. Come on, I know you can do it. I don't think the camera is focusing appropriately in my part, but I think that you guys can see like the quality of the roof, the quality of the layer lines. That's all due to, you know, Method's sort of amazing ability to print, and that's also true with metal, right? Metal is a tricky material to use. It's definitely harder than the rest of the materials, you know, that are available with the Labs platform. But nonetheless, I mean, the quality that you're getting, it's quite exceptional. To print it, I think, you know, one of the first things that you need to have in mind is that you'll probably need an additional fixing element for your build plate. In my case, I've been using DimFX here. So it's a bonding element. You know, it's actually recommended for 3D printing. I bought it also through Matter Hackers, and it's been great, right? It essentially makes your part really stick to that build surface, because very similarly to other polymers with metal or 3116L, you will get, or you might get, a little bit of shrinkage happening as you print. So it's really important to try to keep that part 100% adhered to the build plate. That's, you know, has not to do with, or I guess, a heated build plate, a heated chamber might not do enough. For most of my prints, it's been enough, but you really want to consider having an actual adhesive to help you out with that. So that's step one, right? You'll want to have an external adhesive. I've seen it, DimFX. There's a few others out in the market that you can test out. For me, this has been great. And once you print your part, right, you get the green part, and also as part of the, oh, there we go, that's a proper focus. And as part of the service that you're getting from Matter Hackers, you will get the processing tickets, right? The processing tickets themselves are, well, what the name describes. It's like basically tickets for you to be able to send out the part to them for it to be sintered, right? These parts are not going to be, you know, the sintering process is just not something that you will be able to have in your house. Even if you have, or in your, you know, factory floor, even if you have a printer that's capable of printing metals, the actual sintering machine will set you back a few tens of thousands of dollars, right? So that's why the sintering machines are just not something that you can find around the corner, or that you won't find in any average makerspace, right? That's why you need to rely on a third party to do the sintering for you. Otherwise, it just becomes too expensive to have your own sintering machine. But essentially, you know, you print your part, you send it out to Matter Hackers, and, well, in my case, to Matter Hackers, and that's kind of like our preferred supplier that we've been promoting here. And you get back your finished stainless steel part. The really interesting thing here is I wanted to show you guys the weight of the parts, because it's just hard to convey. Well, outside of the, you know, I've been talking about the actual cleaning properties, so I'll approach it to the mic. You know, that's just to tell you how solid and legit metallic these parts are, but also just look at the weight of the parts themselves. So I'll put these two elements here on the right, and let me remove some of the extra parts, right? So my finished sintered parts here, sorry, to the left of my scale. Let me reset the scale. Zero, it's now in grams, right? And I'm going to put my preferred print of choice, in this case my gripper. I'm sure you guys have seen it in past episodes of chats. So the gripper itself, it's about 128 grams. Just these small things, you know, both of them account for as much weight as my gripper, right? So 131 versus, I'll do it again, 128, right? So about the same weight for these parts as for the gripper. It's crazy to think about the density that these metallic parts have, like the fact that they are completely solid, that they are bulk stainless steel. It just blows my mind. And that's also one of the reasons why we've been saying I think it's better for you to think about metal parts not as a, you know, be-all, end-all, be-all material, but something that you can combine with the rest of your assemblies, that you can actually use smartly in very specific places. And that's one of the things to think about. The The limiting factor here for scale or for size is going to be the sintering process. That sintering process can only accommodate for cubes that are about 100 millimeters cube, right? Anything bigger than 100 millimeters will not fit the oven and will not be able to be processed. So thinking about that, you know, if you have a part such as this gripper and you wanted to add some elements that are super strong for you to be able to use it, you know, I would just focus, and this is what I'm doing, right? I'm replacing just the tips of my gripper here with something metallic so that only the wearing part, the part that's going to be, you know, up against the most forces, up against the most wear, is what I will print out of stainless steel, right? So that I can both save time, save money, save weight, and just focus the strength on the parts, on the areas of my assembly where the strength is really needed, right? So that's what I did here. You know, just showed you guys how heavy or dense these parts are. I'll take you through some examples, some of the examples that I printed so far, removing the scale. Do post the questions if you have them in the comment section there, and I'll try to address as many of them as I can. So first up, let's see if I can bring this a little bit closer. Okay, a little bit closer maybe. There we go. So first up, I've got what I was saying, the gripper tips, right? This is my green part. These are my sintered parts. As you can see, the scale, you know, the shrinkage factor is quite extreme here, as big as much as 20%, a little bit over 20%. It changes depending on the axis, right? Your parts will shrink more on the z-axis versus the x and y. 20% on x and y, about 26% on the z-axis. The actual quality, right? The resolution that you get, the ability to print details, the level of detail that you get, it's really impressive nonetheless. Even with the shrinkage, I'll try to, let's see if it focuses on my hands. It doesn't seem to want to. But the level of detail that you get on these parts, you know, maybe just by keeping it on the table, it's just easier. It's really, really impressive, right? You can see that varying texture. I actually textured that out in Rhino and using Grasshopper, so you can see how the triangles or the diamond tips here change from protruding quite a bit, almost like 3 millimeters, to almost being flat against the surface. And that texture is really nicely captured, and you know, no detail was really lost during the sintering process. Another thing to consider is that because you're using DMFX, because you're really attaching your parts to that build plate, you might have some issues on the very first layer. So far, it hasn't been too bad. It's just been, you know, a little bit of delamination, but nothing too terrible. I think, especially because these are solid parts, it's kind of like straightforward, and I don't mind those issues so much. I also have this grid here. Here, I was just testing, you know, islands, material islands, what happens if I have too many perforations, if I am going to have any issues with delamination or the part itself removing or sort of popping out of the build plate. It didn't happen. This part is not sintered yet. I'm just, you know, just got those in last week, so I'm waiting for my parts to be processed. I haven't sent them out. I did also a three-way manifold, like this three-way pipe, right? It's quite a complex part, and again, you can see both how complex you can get. I'm not using any types of supports here, right? And the quality that you're getting with the printer is just unbelievable. And you know, bear in mind that this printer is the same printer that I am able to just heat print and print carbon fiber. So this mix of material, I think that this is what makes Method really interesting of a product. Just the breadth of materials that you can have, both using carbon fiber, nylon carbon fiber, and now metal parts. It's just, you know, such a great and powerful package to have. The quality, you can see, like, there's a few layer lines here happening. I don't know how those will be reflected in my final sintered part. You know, everything that's shown in your printed part will probably be reflected some way in the sintered part, but still, like, the fact that this is 100% metal and it was printed in a platform that starts at $39.99. Of course, I'm trying to make an ad here for the printer because I really like it. I really believe in it. But it's just, you know, honestly, I've been surprised. I was expecting it to be a lot harder than it was, and it just hasn't been, right? I got here another example, which is the one that we got on the website, this solid gear. It's just, you know, let me bring back the scale. because the weight, the actual density of the material that I'm getting, it's just hard to believe. So 0, I'll do it in grams, and then I'll turn into ounces. So in grams, this part, it's almost 400 grams for a part that's like barely the size of my palm. If I change this to ounces, so almost 14 ounces for that part. You know, when you compare this part to my whole gripper assembly, the gripper assembly is like 4 ounces. The gear here, it's almost 14, right? So 10 ounces more in such a small package. It just tells you just the sheer density of the parts. Let me zoom out so that you guys can see a little bit more of it. So again, 13.4 ounces, 4.4 ounces. It's almost 10 ounces difference for a part that's, you know, 3-4 times the size. So really impressive. This one, you know, of course, when you're printing metal, you have to print lattices. I've been playing with them topology a little bit, some extra plugins for Grasshopper, and the same. So as long as you can play with supports, look, you can create very complex parts as long as they don't require supports, right? If you find a way to bypass the supports, you know, that's what's happening here with my pipe, right? Very complex parts that they don't necessarily require support. So this, this cube also, it's like fairly complex on its geometry, but since it doesn't require supports, it's straightforward to print, straightforward to sinter, and it's just a really neat example of what you can get with metals. I'm going to finally jump to MakerBot Print here. Just to show you guys, I am actually printing another gripper right now, like the tip of the gripper here. And it's essentially the same, you know, the same process as you would have with any other material from labs, right? We will have dedicated printing profiles for metals. I don't think that they are live right now, but I'm using the same platform, the same sort of overall levers for me in the printer for me to be able to print metal. So just the fact that it's giving me that extra range of possibilities with metal, it's just, I don't know, for me it's super exciting. I'm going to jump into the questions just to see what's out there. So if you have any questions, do post them in the right hand comment section, and yeah, let's get into it. Does the green part already have, and let me just mix my view here because I want to have, better to have the parts themselves and my camera than just my face. Does the green part already have some mechanical strength? Yes, the green part itself, it's actually fairly strong, fairly dense, but it's kind of brittle. It's hard to describe it. I think that the closest thing I would be able to compare it to would be ceramics, right? It's kind of like when you first do, just when you're using ceramics and you sort of finish up your shape. It feels strong, but not super stiff. It feels, I don't know if I can break it, but I wouldn't want to do it because I really want to sinter these parts out. So yeah, it has some strength, but you definitely need to sinter it for it to perform as expected, right? For it to actually be 100% stainless steel, it has to be sintered. Otherwise, it's going to fail. It's not going to give you the mechanical properties that you're looking for. What's the shrinkage with this material, percentage with this material? So it's about 20% in X, 20% in Y, and 26% in Z. The reason why Z, and I was talking to BASF the other day, the reason why Z shrinks a little bit more is because the weight of the part itself will push some of the material down. You know, in X and Y, you don't have the excess weight. There's no forces pushing from the sides. But in Z, you have that extra 6% due to just the sheer weight of the part itself. Can I use support materials for this filament? Unfortunately, no. And even if you wanted to use like breakaway supports, I wouldn't recommend it just because you have to take into consideration also the sintering process, right? If you're using supports and you remove them, you know, before the sintering process and send it to sintering, the part is going to fail during sintering. It's just going to collapse under its own weight. Do you recommend printing at 100% infill? I'm actually using 90% infill. That's close to 100%. It's about the same when you consider the shells and everything else. But the print profiles will be available for you guys to just use from both MakerBot Print and Cloud Print. Is the oven time the same for all parts, or is geometrical size dependent? That I don't know, but it's also something that falls into Matter Hacker's end. So they will be able, they will take over that processing part for you. There's no change in the fee depending on the size of the part. It changes depending on the weight of material that you're sending over, right? I think that the limit is like, if I'm not mistaken, 500 grams. I would need to check that out. But you don't need to change, you don't ask for a specific cooking temperature, you don't ask for a specific sintering temperature. You just send out the green parts and get back the stainless steel parts. They'll take care of the rest. After sinterings, do the layers hide a bit? Let me show you. So the straightforward answer is, I don't think so. It's what you see in the green part is going to be really close to what you see in the sintered part. Let me see if my camera is doing a good job at capturing this. So green part, sintered part, and of course, they're not the same part. One of them was the green part before, but you can see like the layer lines in the green part are, I would say, barely visible there. Let's see. Come on, you can do it. I'll wait for it to try to focus, but you can see them a little bit in the green part, and in the sintered part, they do hide. The good thing about the sintered part is that you can actually post-process those parts, right? So I could sand this part and get essentially almost that shiny look, that shiny stainless steel look out of the part, which is really nice too. So something to consider, with the sintered part, you have, this is 100% 3116L steel, right? So you'll be able to actually sand it, polish it, everything that you would expect to do with a 100% metal part. So that's great. Specifically about the layer lines, they won't magically disappear with the sintering process. They'll change a bit, not a lot. If you see issues, if you see layer delamination, then you'll probably also have that or those reflected in your sinter part. It's not going to solve for that, right? But because of the way that method prints, I think that the quality of the layer lines is also already so, there we go. It's already so good and so hard to discern that you'll be getting really successful results right at the bat. Like, just look at that texture, right? The diamond texture right there, just amazing to see. For me, it's amazing to see. What are the print temperatures and speeds? We are printing at, so the chamber, it's at 60 degrees Celsius. The extruder is at 240 degrees, and the speed, that's not changed. We're using the same ABS profile here. But as I said before, this print profile will be available for you to just use through both MakerBot Print and Cloud Print. Recommended printing parameters and settings for the material, as I said before, 60 degrees in the chamber, 240 in the extruder, but we will make the settings available for you guys to use directly from MakerBot Print. Is there a significant shrinking after ovening the part? If so, is it considered during the printing of the green part? That's a great question. So as I said before, yes, there's a significant shrinkage of the part happening during the sintering process. With MakerBot Print, the new slicing profile will take account for some of that, but it is uneven, right? It's not like super controlled. We know that it's about 20% in X, about 20% in Y, and about 26% in Z. But it's not something that you will be able to 100% control, and especially keep the tolerances as tight as you would expect with the part that came out of the printer. One thing that I would recommend, and I think that this is a good example too, right? I have my gripper here. These front claws are actually I'm taking the exact same geometry from the gripper and sending it out for sintering, right? As you can see, the geometry is fairly close. So even with MakerBot Print, actually, we accounted for that shrinkage, and the part is really, really close to the actual spec part. It's not 100% there. It's not as close a tolerance as you would get with ABS, right? Or with carbon fiber, for that matter. But it's really there. If you need the part to be really, really, really spot on, I would recommend printing your metal part, sintering it out, measuring it again, just to make sure that you get the formation right, and then adjusting your plastic component on to the metal part. Let's see if we have any more questions. How susceptible to moisture is the filament? What kind of drying cycle would you suggest? So I am not sure. I don't have enough experience with it yet. It doesn't seem to be too finicky, you know, especially if I compare it to nylon 6 carbon fiber. This is definitely more stable, but I would say do keep it dry, do keep it in a drawer or in a closed environment. I use the Mylar bags that come with the material, and that's been great. Can debinding and sintering be done without outsourcing? Well, yeah, but you would need to buy your own debinder or sintering machine, and those are like, I don't know, $40,000. So yes, but you need the machine, and it will probably be, or likely be, much more expensive than the printer itself. Will there be different nozzle sizes for the labs extruder? No, and actually right now, that's a good question. So the labs extruder is what what you will be using to print the metal material. Right now, the nozzle size itself, it's 400 microns, and that's our standard at MakerBot, and it's been working perfectly well for this material. At the moment, we have no plans on releasing additional nozzle sizes, but again, this is another sort of fun print that I did on my end here. Just look at the resolution and the quality of the texture, right? It's just super smooth, super nice. I'll let you guys know what happens after these parts have been sintered, but I'm just super excited to be playing with this new material. And I think we're just about out of time, so I'll just take one more question and then I'll call it a day, but we'll probably do a follow-up later on. So should the extrusion width and wall thickness match the extrusion width? Yes, that's a good point. So ideally, in our case, the wall thickness is usually 400 microns because it's related to the nozzle size itself. If you think about having two walls, that means 0.8 microns, 0.8 millimeters, and that's a good ballpark to use. Just keep it closer, especially when you're doing very tiny features, to keep it close to a multiplier of the